this question is based on the rotating oranges. So in this question, what I got. So in this question, there are m cross n matrix where we contain 0, 1, 2. Where 0 represent an invitation and 1 represent a fresh orange and 2 represent a rotating orange. Okay. So what we have to do, we have to just convert this all fresh oranges to rotten oranges, and the all fresh oranges will converted into rotten oranges by these rotten oranges. Okay, but it means at every hour the fresh oranges will converted by the rotten oranges by the four directional. Okay, so what I'm saying to you, you can understand by this, like if we have something like this type of matrix, type grid, like 2, sorry, like 2 0 1 1, sorry, 2 0 1 0 0 1 1 1 0 0 0 0 0 0 0 0 0 1 1 0 0 1 1 2 0. Okay, so when so these two represent the rotten oranges. Okay, this 2 is a rotten oranges and this one is a fresh oranges. This one is a fresh orange. Okay, so what we have to do, we have to just convert these fresh oranges to rotten oranges. Okay, so our target is to convert this 1 into 2, which means 1 is fresh orange, 1 is fresh oranges, then we have to convert 1 to 2, then it becomes rotten oranges. Okay, and this fresh oranges will converted into rotten oranges by these rotten oranges, by this rotten orange. Okay, this one will converted into 2 by this rotten oranges. Okay, so how we can convert this one, we can convert this one by this 2, by this 2 rotten oranges. Okay, so how we just apply a BFS from that position, and then we reached at this position and make this is rotten, make this rotten, and then we apply BFS at this place and make this rotten and convert it into rotten and oranges. So every time we take a one step, and this one step is called 1 hour. Okay, so we take one step and make rotten, and we take one step and make rotten, and we take one step and make rotten, and we take one step and make rotten. So total we take 4 hours to make all this rotten, all this fresh oranges to rotten. And here also we take, this is our rotten, this is our rotten orange. Okay, we apply a BFS and make all this to fresh orange to rotten oranges, and apply again BFS and make this all to rotten oranges, and we take 2 step here. What we take 2 step here, so we take a 2 hour. Okay, so after that there are every one converted into 2. So after that the all fresh oranges will convert into rotten oranges. Okay, so how many maximum step we take, we take a 4 step is maximum. So minimum we take a 4 step to converted all ones to 2. It means all rotten into all fresh into rotten oranges. Okay, so we take maximum 4 step to convert it all ones into 2s. Okay, so how we can achieve this, we just understand by our we just apply a BFS, so you can understand what I'm saying to you. So you have to just figure out what I'm saying to you. By this again, we just draw again, like 2 0 1 0 0 and 1 1 1 0 0 0 0 0 0 0 0 1 1 0 and 0 1 1 2 0. Okay, so this is a 0 1 2 3 4 0 1 2 3 4. So we take a cube, we apply from BFS from these two. So we initially add these two. So in the initial condition we add this rotten oranges position, this position 0 0, and this is position is, and the position of that two number is 4 3. Okay, 4 3. Okay, when this 0 0 will remove, when this 0 0 position will remove, then it will add his neighbor. Like when we apply BFS, then it will add our radius. His radius is 1, his radius is this radius, and we take a 1 step, and when we take 1 step, then it will add our neighbor, and the neighbor is 1 0 1 0. Okay, and then 4 3 will remove, and then 2 will remove, and 2 will add our neighbors, and his neighbor is, when you apply BFS, then the neighbor is 4 2 4 2 and 3 3. Okay, So after that when 1 comma 0 will remove, after that this 1 comma 0, this 1 comma 0 will remove, then it will add our neighbors like this position. So when 1 comma 0 will remove, then it will add, then when 1 comma 1 will remove, then it will add 1 comma 1. Okay, then it will add 1 comma 1 position. Okay, then after that, this is our first step, this is our first step. Then it will take 1 hour. When this 2 and 2 will remove, then it will take 1 hour to reach at this place. So this is our first step. And then after that, this our second step. At second step, we just remove our 1 comma 0, then it will add 1 comma 1, and then when 4 comma 2 will remove at this stage, then it will add this neighbor. It makes this 2 2. It is also converted into 2, and it also makes this 2, and also it makes this 2 2. And then it will add 4 comma 2 will add our neighbors, this and this. So the position is 4 comma 1 and 3 comma 2. Okay, then it will add 4 comma 2, sorry, 3 comma 2 and 4 comma 1. Okay, and this will remove, and also 3 comma 3 position is this. It will also remove, and it can't be moved here, and it can't be moved here because this is converted into rotating origin, and also it can't be moved here, and also it can't be moved here. So it will remove, and it will not edit any other routine in any other place origin. Okay, because this will not, there are not any condition, it can't move anywhere. Okay, so what type of position we have? 1 comma 1, 4 comma 1, 3 comma 2. 1 comma 1 is this, and 4 comma 1 is this. 4 comma 1 is this, and 3 comma 2 is this. And here also, when 1 comma 1 will remove, this 1 comma will remove, and it will add, and it will add the next position 1 comma 2, this position, this neighbor. And then when 4 comma 1 will remove, then it will not add any other, because all the sorry, this 4 comma 1 will, it can't move anywhere, so it will just, it can't be move anywhere, so it will just remove, and it will not edit any other place origins, because this have no any condition to reach anywhere. Okay, so after that 3 comma 2 will remove. 3 comma 2 position is there, and it also have no any position to going to anywhere. It also have no any position to going to anywhere, so it will also remove, and it will not add anything. So we reach here 1 comma 2. Okay, when 1 comma 2 will remove, then it will add this, then it will add 0 comma 2. Okay, so at this stage, this is our second stage, this is our third stage, and this is our fourth stage. So every time we apply a BFS, first hour, second hour, third hour, fourth hour, so all step is counted as a hour. And after that, when 0 comma 2 will remove, then we found out that all phase oranges will convert it into rotating oranges. Then all phase oranges will convert into rotating oranges. Okay, so this is our explanation. This is our solution, that not any oranges, phase oranges will remain. Like anywhere we doesn't get 1, everywhere we converted into 2, everywhere we converted 1s into 2s, everywhere we converted 1s into 2s, everywhere we converted 1s into 2s. Okay, so this is our rotating oranges explanation. So after that, we are going to apply the BFS at initial rotate, and then you just understand what I'm saying to you. Okay, so we are going to code it. Okay, we are going to code it. So for code it, we just check initially. We just check our grid dot size. If our grid dot size is 0, then we just return. What we have to do? We just return 0. Okay. And int, we just find out our row by this grid dot size, and we just find out column equal to grid dot column. Okay, sorry, grid dot column, no, grid 0 dot size. Okay, and then we just go and take a q, and there are we made a pairs, and we take a q. So after that we take a int fresh. What do you mean by fresh? Fresh is denoting that we have a fresh orange. Okay, the fresh orange which will not convert it into rotten orange. Okay, so now we just traversed our grid. Okay, we just traversing our grid using 2D matrix, using 2D traversal, where we go I less than grid dot size, sorry, I to row, comma, I plus plus for int j equal to 0, j less than call, comma, j plus plus. Okay, and then we just take a pairs, then we just check, then after also we check that anywhere our grid is presented, our routine orange is presented. So by checking, we just check grid ii equal to 2. If grid ii equal to 2, then what we are doing it, then we have to just add, then we have to just find the pairs x, we have to just find our position. For our position, we make a pair of I comma j. At this position we make a pair, and we add this pair into q not plus what, x. Okay, and else if what we have to do is we just check grid, we just go and check grid I j equal to 1. Then what we have to do, we have to just increase the press. Okay, so we have to just increase the press, so it will tell that how many fresh oranges will be presented in our grid. Okay, so it will tell that how many type of fresh oranges will be presented in our grid. Okay, so after that if our fresh oranges will 0, then it will tell that no any fresh oranges will presented to converted into rotten oranges. Already there are no any fresh oranges, so we just return 0. So we don't need to be move forward to find out solution. We just pause here and return 0. Okay, but if you don't get any fresh equal to 0, then we have to move forward and we take a count equal to 0, which count our steps to provide a BFS, to apply a BFS. Okay, this count 1 will count that how many times we have to apply the BFS. Okay, apply the step to reach at all fresh oranges. Okay, so we just take a direction array. Why we take a direction array? Because we have to move in all 4 directions for applying the BFS. To move in a maze, like in a grid. Okay, -1 comma 0, and then we take, sorry, I think there are 1. We take 1 comma 0, and then we take a 0 comma 1, and then we take a 0 comma -1. Okay, 0 comma -1, and then we just decrease the value, and here. Okay, here what we get a direction 4 comma 2, direction 4 comma 2 equal to 1 comma 0 and -1 comma 0 and 0 comma 1, 0 comma -1. Okay, so this is our direction array. Okay, and then after that we put a while, and here in this while we just check q dot size is not equal to 0. Okay, q dot size is not equal to 0, and then what we have to do, we just go and increase the count. It will tell that how many steps we have to move, how many steps we take. Okay, and then we take a size, and q dot size. Okay, and we take a size, and we find out how many times we have to move to find out our routine oranges. Okay, how many times we have to rotate, how many times we have to provide a loop to find out how many routine oranges will present. Okay, So int I equal to 0 and I less than sz and I plus plus. Okay, and then we have to check, we have to find x equal to point. So we have to move our, so we have to just, so what we get, so we are just traversing our queue. We have to, how many times we have to find out rotate oranges, we just find out by this loop. Okay, so we just take our here point, so this is our rotate oranges position. Okay, equal to q dot front, q dot front. Okay, q dot front, and then q dot pop. Okay, q dot pop. Okay, and then also after that we apply all four direction. Okay, int j equal to 0 comma j less than 4 j plus plus. Okay, j plus plus at the end. After that int j equal to int x equal to x, int x equal to point dot first plus dirs j 0 and int y equal to point dot second plus dirs j 1. Okay, okay, after that what we have to do, we have to just check out that if x less than 0 or y less than 0, it will tell the condition that can be moved at the all conditions, can be moved, the x can be moved. What we are doing, we just apply a BFS in all four directions. Okay, so we just go and check out that can be moving x less than 0, can be moving y less than 0, can be, it will be negative, no it will not be negative, it can't be beyond the our grid. So we have to just put x greater than or equal to row and or y greater than or equal to column. Okay, and also we just check that we can't move to add grid y equal to 1, and also we cannot move at grid x comma y equal to 2. Okay, so this is our condition where we cannot move. Okay, so if x is less than 0 and y less than 0 and x greater than or equal to row and y greater than or equal to column and grid x comma y is greater than 1, so at these conditions we can't move. Okay, and all that condition we have to just continue. Okay, so we can't move at this stage, we just move to find out our next rotation, because we cannot move from that position. Okay, so because this is our false condition, if this condition will be false, if we are going to at a valuable space, at a good space where this condition is not false. Okay, so at this stage what we have to do, we have to just make a grid, x comma y equal to 2. Okay, equal to 2 and points z equal to, sorry, we take a pairs z equal to make pair it, where we just put x comma j, x comma y. Okay, so it will make a pair of x comma y, and then we just add that position into z, then it will add this oranges, because first we make this oranges will rotate, oranges position will rotate, and then we'll push that position into q. Okay, because this will add it, and then fresh minus will tell us that our this fresh oranges will convert into rotate oranges, because they will be converted into 2 now. So this orange will convert into rotate oranges. Okay, so after that what we are doing, After that, what we're doing, after that all conditions, what we check, we just check out if fresh, we just return what we return. If fresh equal to 0, then if fresh equal to 0, then we just return count. If it is not valid, then we return minus 1. Okay, what we're saying is if fresh equal to 0, then we return count. If it is not valid, then we return, then what will return minus 1. It means if we doesn't get any fresh value 0, then we are just telling that how many we take a step to make all fresh oranges will convert into rotten oranges. If we doesn't get any, if we get a fresh oranges value is greater than 0, then it will say that there are some fresh oranges will remaining. Okay, so this is your code. We just go and check out again this code. So first we check the grid. If grid dot size equal to 0, then we return 0. Okay, and then we check a row. We take a size grid dot size equal to row, and we take a grid 0 dot size equal to column, and then we make a queue of pairs class. Okay, and then we take a place equal to 0, and we just traverse the whole grid, and if we got a 2, then we make a pair of that position and push into queue. This is a position of a rotating oranges. Okay, rotating orange. Okay, and else it. And if we got a 1 position, if we got the position where our value is 1, then we increase the fresh value, and this fresh value will count how many fresh oranges will presented. And if we get fresh value equal to 0, then it will return 0. Okay, and then we take a count 1, and we just increase the count to tell us that how many we take a step to reach at fresh oranges. Okay, this outer loop will tell how many steps we take to reach at the fresh orange to convert into rotten orange. Okay, after that we just apply the VFS. So q dot size, and we take I equal to 0 to size, and we just take a point, take a pair, and then also we just pop the value, and we apply the VFS, breadth first search, to reach at the stage, and then we just apply this, and then just return. Okay, so now we have to just run it and check out if we got some error, and we get some error. So what is error? I think we just got at error pairs. Okay, so there are pairs. I think we just tried pairs. Okay, so now we have to run again. So now what we error get at the last stage 63. I think we get some error here. What error? Check out again. Return fresh expected before token. I think it will tell something. It will tell us that okay, here this will write that this system. So now, oh, this is wrong. Why? Oh, sorry. We take a count equal to 1. We should take a count equal to minus 1. Okay, so now it will run properly. Oh, sorry, why it is going to be take error? We increase our count or not? Or we increase our count and we just keep the fresh value equal to 0. Of course we keep the fresh value equal to 0. If fresh equal to 0, then it will return count equal to 0. If fresh is something, then it will not return the count equal to 0. Why? Oh, what type of error we get? Oh, okay, sorry. So there are, we just put a 1, so we have to just put a 0. Okay, so we just run it. So it accepted and then submitted. Then this is the correct answer. So I hope you understand what I'm saying to you. So this is our answer, and please subscribe the channel, and thank you.